In this video, I'm going to talk about filters. Filter is nothing but it is a device which allows a desired signal and rejects unwanted signal. So it's basically an electronic device. There are two types of filters. One is active filters. Active filters are made with operation amplifiers or transistors. Another one is passive filters. Passive filters are made with resistors, inductors, and capacitors. Now, both active filters and passive filters further divided into four categories. One is low pass filter, high pass filter, band pass, and band stop. Low pass filter is nothing but it allows signal at low frequency. So x-axis is omega, y-axis is a signal, whatever that signal is. For time being, I'm going to take that as hj omega. So low pass filter, it allows signal at low frequency. High pass filter, same thing, it allows signal at high frequency. So once it reaches a certain frequency, it starts allowing the signal. Band pass filter allows a signal between two frequencies. So this is where you see the output between omega and omega 2. And band stop filter is it stops signal between those two frequencies and allows signal other than those two frequencies. So those are the four types of filters. Now I'm going to talk about low pass filter. As mentioned, low pass filter is nothing but it allows signal at low frequency. So simply here is a RLC circuit. So the output is taken across the capacitor, or capacitor is 1 over j omega c. So here the transfer function is j omega equal to V naught over V input. V naught output voltage is nothing but if I take the current passing through this is I times 1 over j omega c, and the input voltage is nothing but I times R plus 1 over j omega c. So here is the transfer function for this RC circuit. Now if I find the magnitude for this transfer function is nothing but 1 over square root of 1 square plus omega square R square plus C square root of. Okay, now this omega c is called the cutoff frequency. As long as omega c equal to 1 over RC, that value becomes 1 over square root 2. So the cutoff frequency is nothing but, I'm showing you a straight line here. I'm saying this is the low pass filter, but in reality with the passive elements we cannot build a square or rectangle like this. Okay, the signal is going to go down exponentially in RC circuit, because if you remember, capacitor does not allow sudden change in voltage. So the signal is going, as low frequency, say frequency is 0, that means that's a DC supply. At DC supply, capacitor is going to act like a open, so you will see the maximum voltage right there. Okay, as frequency increases, then the voltage drop across the capacitor is going to go down. So it's exponential form. So once it reaches to the 70.7%, that's where it's going to cut out the signal. Okay, it allows signal until the voltage across capacitor reaches to square root 3 times V naught, initial voltage across the capacitor. Next one is high pass filter. So in high pass filter, same thing, it's a RC circuit. Okay, now I'm going to take the voltage, output voltage across the resistor instead of capacitor. So our transfer function equal to hj omega equal to V naught over V input, which is I times R, assuming I current is passing through this, divided by I times R plus 1 over j omega c. So I get cancelled out. I will end up with j omega equal to j omega RC divided by 1 plus j omega RC. That's hj omega. Okay, so to get the cutoff frequency here also, I'm going to take that as omega c as long as omega c equal to 1 over RC in this case, then that's where the cutoff frequency is going to happen. So the cutoff frequency is going to be, so the voltage drop across the resistor at zero frequency, that means DC. In DC, capacitor act like open circuit, so we will see all the voltage drop across capacitor. So across resistor it's going to be zero, but once the frequency is increasing, as frequency increases, that's omega, the voltage drop across capacitor, or sorry, across resistor is going to increase. Okay, so this is also at 70%, say, that's omega c, cutoff frequency, which is square root 2 times that's the square root 2. Okay, so here so as long as the voltage across resistor reaches to square root 2 times Vn, that's called the cutoff frequency. So from here it's going to allow the signal. So this is called high pass filter, because it is allowing the signal at high frequencies. Now the next one is band pass filter. Band pass filter. So in band pass filter, it allows signal between two frequencies. It is designed to, let me write it down. So band pass filter is designed to pass all frequencies within a band of frequencies, as long as your frequency is within omega 1 and omega 2. I believe omega 1 and omega 2 are half power frequencies. As long as your frequency is within those two, it is going to allow the signal. For this, we're going to have RLC series circuit. Okay, and I'm going to take my output across R. Okay, so here H omega equal to V0 over Vn. Okay, I'm assuming current is same, I ampere. So I times R over I times R plus J omega L minus omega C. I get cancelled out. So V0 over Vn, that's a transfer function, equal to R over R plus J omega L over omega L minus 1 over omega C. Now if I draw the graph, here is my omega. Okay, so it's going to be something like this. This is my V0. I'm talking about V0. Okay, so it's good. These two are the half power frequencies, omega 1 and omega 2. It is omega 0. Okay, so it is going to allow signal between omega 1 and omega 2. Okay, so this omega 0 in this case is 1 over square root LC. If you remember, that's the resonant frequency in RLC circuit, RLC series circuit. It's the same thing for RLC parallel circuit also. Okay, so band pass filter, it allows signal between two frequencies. Now the last one is band stop filter. So you can see it stops signal between those two frequencies. So here is my V0. So I'm going to take my output across L and C. So here also Hj omega equal to V0 over Vn equal to J times omega L minus 1 over omega C divided by R plus J times omega L minus 1 over omega C. Okay, so here also if I take the resonant frequency, it's going to be 1 over square root LC. So my output is going to be as frequency changes. So x-axis is frequency, y-axis is my output. My output is going to be something like this. Okay, so if we look at here, it's going to allow signal. So this is omega 1, that's omega 2. It allows signal between these two frequencies. Okay, so what is this? This is called cutoff frequency, which is square root 2 times V naught. That's the same value, square root 2 times V naught. Okay, and here is omega naught. Okay, omega naught is the resonant frequency in RLC circuit. These are the passive filters. That's all. I'm done with this chapter. I'm going to start the new chapter in the next video. Thank you.